Hey ANPers, this is Dr. Jones checking in. This is ANP1 lecture test for video 10, covering page 11 on the Noteset. So in the previous video we did the steps, what do they call it? The steps that initiate a muscle contraction. And now we have the steps that end a muscle contraction, which is actually a little bit different than muscle relaxation. You can end a muscle contraction without relaxing it. When my eldest was quite young, he liked to do the thing, but he didn't quite understand how it went. He was very small, and he did not actually contract his muscles. He just held them up and said He wasn't like he wasn't like contracting. He was just holding them there. So when you contract a muscle, you can stop contracting it, but that doesn't relax it, that doesn't make it go back to its initial position, which we will talk about more. But let's talk about how to end the muscle contraction. Okay. Number 6, the ACHE eats the ACH. So the acetylcholinesterase, those were the little moon shapes in here, the little enzyme bits. And we said that the acetylcholinesterase, the ACHE, breaks about half of the acetylcholine down before it even reaches the motor end plate. I think a small bug just landed on me. Okay, great. And then after you stop getting the message to contract, you stop releasing the acetylcholine, and then the acetylcholinesterase eats all of the leftover acetylcholine. And then 7, there are pumps, calcium ion pumps. And these are active pumps, which means they do burn ATP. So this is a second step in muscle contraction that burns ATP. The first is releasing the myosin heads from the thin filaments. And here's a second one, calcium ion pumps, which actively burn ATP to pump the calcium back into the sarcoplasmic reticulum. Now here we're calling it the SR. It could be the SR, it could be the terminal cisternae of the SR, but that's still part of the SR. So when we're talking about the sarcoplasmic reticulum, we are including the regular sarcoplasmic reticulum and also the terminal cisternae part of the sarcoplasmic reticulum. Okay, and now without calcium, the troponin goes back to its normal shape, holding the tropomyosin on the active sites on actin. So these active sites are now completely covered. So we cannot have cross-bridge interaction. No cross-bridge interaction, nothing there. And the contraction ends. So we're no longer attached with cross-bridges. And this is relaxation, which is not a return to resting length. We have a passive return to resting length, which we are about to talk about. Next, let's talk about it. So, relaxation. Let's get me out of the way here. Okay. Contraction will only continue if there are more nerve action potentials arriving at the neuromuscular junction. Nerve action potentials arriving at the neuromuscular junction. When they do, the release of acetylcholine keeps making action potentials. So let's review this. The acetylcholine is released into from the synaptic knob, the synaptic vesicles and the synaptic knob, into the synaptic cleft. where they bind to acetylcholine receptors. So as a review, when the acetylcholine binds to the acetylcholine receptors, what exactly is it that enters the cell? Is it the acetylcholine? No, of course not. What enters the cell is sodium. Because sodium is positive and the inside of the cell is generally negative compared to the outside of the cell, and we have changed this transmembrane potential by allowing a boatload of positive ions into the negative inside of the cell. And this difference here is, of course, the transmembrane potential. And we have changed the transmembrane potential, which is called an action potential, which we usually draw as a red lightning bolt. And so it's this entry of sodium ions into the cell that is the muscle action potential. And that is propagated down the length of the sarcolemma, which we are not discussing in this chapter, but we will discuss for test 5. And it also travels, that's a zigzag, down each and every T tubule. And each T tubule is touching 2 terminal cisternae, and the 3 together are called a triad. I should have changed colors. And what's the magic? We were supposed to be doing relaxation. We'll get there. What's the magic about... We should do relaxation now. This is the relaxation video, isn't it? I got off track. It was a nice review, though. Okay, so let's keep up with the contraction there, just because this is a nice picture, so let's review. So when the muscle action potential reaches the T tubule, that change in voltage activates the calcium ion channels, the voltage-gated calcium ion channels in the terminal cisternae, and release a bunch of calcium. The calcium then binds to troponin that holds the tropomyosin in place on the active sites on actin. And when the calcium binds to the troponin, it changes its shape, and that pulls the tropomyosin off of the active sites on actin. And then what binds to the active sites on actin? The myosin. And then it hinges. I'm trying to hinge the wrist here, and I don't have enough room in screen. So, and that when the myosin binds to the actin, that's called a cross bridge. And then the power stroke, where the myosin heads bloop on their little hinge, and that pulls the Z lines closer together because it pulls the thin filaments closer together, closer to the M line. Until we stop with the nerve action potential. When we stop the nerve action potential, we stop releasing acetylcholine into the synaptic cleft. And that allows the acetylcholinesterase time to clean up the synaptic cleft and break all of the acetylcholine down into their constituent parts, the acetate and the choline. So now we no longer have positive ions flushing into the cell, changing the transmembrane potential. So we no longer have a muscle action potential sweeping down the sarcolemma or the T tubule or activating the voltage calcium ion channels in the terminal cisternae. What we do have are calcium ion pumps in the terminal cisternae and the rest of the SR that pump the leftover calcium back into storage in the sarcoplasmic reticulum. And that includes, of course, the terminal cisternae of the sarcoplasmic reticulum. So without calcium, the troponin goes back to its normal shape, pulls the tropomyosin back on the active sites on actin, so we can no longer form cross bridges. The myosin can no longer bind to the myosin binding sites on actin. What were the myosin binding sites on actin? The active sites on actin. Quick review, actin, thin filament or thick filament? Thin. And what was the thick filament made of? Myosin. You got it. Okay, relaxation. So contraction will only continue if more nerve action potentials arrive. When they do, they keep releasing acetylcholine, which keeps making action potential, which keeps the calcium elevated in the sarcoplasm. Under these, the contraction cycle keeps repeating several times a second. The most important mechanism for reducing the sarcoplasm levels back to normal is the sarcoplasmic reticulum calcium ion pumps that pump calcium back into storage in the SR. Do sarcomeres automatically return to resting length? No. They have a passive return to resting length. Muscles can pull, they cannot push. My tricep pulls to undo what my bicep did. So these two muscles work against each other, so they're called antagonists, which we'll get to. So pull, no push, which is tension, no compression. And rigor mortis, here it is. We run out of ATP to pump the calcium back into the SR, and also run out of ATP to break the cross bridges. Remember, there's two places where the ATP is required in the muscle contraction. It starts 2 to 7 hours post-mortem, lasts 1 to 6 days, and eventually the lysosomes will dissolve the Z lines, the actinin, and the titin. So, all right, tension production. Section 10.5. The amount of tension produced by an individual muscle fiber ultimately depends on the number of pivoting cross bridges, which is what we just learned as power strokes, pivoting cross bridges. And each individual muscle fiber is either on or off. And this is called the all or none principle. And I do want to bring your attention to the PLE here. There's two spellings of principle. The person who was in charge of your grade school was a PAL, so that's your principal as a person. A principle as a concept is a PLE principle. Okay. Well, y'all are college educated now, and spell check will not help you out with these words that sound the same but are spelled differently based on how you're using them. College educated. Okay, and muscle tension also varies on the amount of overlap in the zone of overlap, which is effectively the resting length at stimulation. And number 2, the frequency of stimulation. Frequency is how often. So how often is it stimulated? Once every 3 years or once every 3 seconds makes a difference. Okay, and that impacts the calcium levels, because if you stimulate it, let it release, and then stimulate it again, the calciums aren't all pumped back into the SR, and so the amounts grow over time, which we will see in the next video, because that was the end of page 11, which makes us the end of video 10. So this has been A&P 1, lecture test 4, video 10, covering page 11. Thank you, as always, for tuning in. It's good to virtually see you here. Just keep studying. You can do it. And honestly, this class is supposed to be a pain. If this class is not a pain in your life, you're not trying hard enough. You can do it. Dr. J out.